With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I hope you all are doing good. So today our question is like this. Formaldehyde polymerizes to form glucose according to the reaction. This is formaldehyde and it polymerizes to form the glucose. This is the reaction we have. The theoretically computed equilibrium constant for this reaction is found to be 6 into 10 to the power 22. Okay, so equilibrium constant for this reaction is 6 into 10 to the power 22. Okay. If 1 molar solution of glucose dissociates according to the above equilibrium, if 1 molar solution of glucose dissociates, okay, now glucose is dissociating according to the above equilibrium, the concentration of formaldehyde in the solution will be, we need to find the concentration of formaldehyde in the solution at equilibrium. Okay, our options are 1.6 into 10 to the power minus 2 molar, 1.6 into 10 to the power minus 4 molar, 1.6 into 10 to the power minus 6 molar, and 1.6 into 10 to the power minus 8 molar. Okay, so this is a very basic question, guys. Okay, so we have a reaction like this. First of all, we have a reaction like this. We have 6HCHO, that is formaldehyde, polymerizes to form glucose like this, C6H12O6. Okay, and we have given the equilibrium constant for this reaction, that is Kc for this reaction is 6 into 10 to the power 22. 6 into 10 to the power 22. This is the Kc for this reaction. Now we have if 1 molar solution of glucose dissociates according to the above equilibrium. So glucose will dissociates like this. So glucose dissociates on the equilibrium will be like this, C6H12O6. Okay, this is the polymerization of formaldehyde. So dissociation of glucose will be like this, and this will be at equilibrium like this. It will be dissociates into 6HCHO, that is into formaldehyde. Okay, so this is the dissociation of glucose. Okay, so this reaction is the inverse of this reaction. Okay, this reaction is the reverse of this reaction. Okay, I hope you guys are understanding it. If this is first and if this is second, then second reaction is the reverse reaction of the first. So its Kc will be Kc, that is equilibrium constant for this reaction will be inverse of the equilibrium constant of first reaction. So it will be like this, 1 by 6 into 10 to the power 22. This will be the Kc for this reaction. I hope you guys are understanding it. Okay, Kc for this reaction, that is dissociation of glucose, the Kc equilibrium constant for this reaction will be Kc equals to 1 by 6 into 10 to the power 22. Okay, now we have if 1 molar solution of glucose, initially we have 1 molar. Okay, at t equals to 0, we have concentration of glucose as 1 molar, and initially we have 0 concentration of formaldehyde because at the start of the dissociation there is no formaldehyde present. Okay, so when the equilibrium is attained, that is at time t equals to t equilibrium, let x concentration of glucose is dissociating. Okay, let x concentration of glucose is dissociating, so rest concentration of glucose will be 1 minus x, and the formed concentration of formaldehyde will be 6x. Okay, this is how we write the concentrations at the equilibrium. If x concentration is dissociating at equilibrium for the glucose, then formed concentration at equilibrium for formaldehyde will be 6x because stoichiometric coefficient of formaldehyde is here 6. Okay, we have to find the value for concentration of formaldehyde, that is value for 6x. We have to find the concentration of formaldehyde, that is 6x value. Okay, so Kc will be, expression of Kc for this equilibrium will be, it will be concentration of formaldehyde, that is HCHO, to the power stoichiometric coefficient, that is 6, divided by concentration of glucose, that is C6H12O6. Wait a second, guys, let me write it more clearly. Okay, it will be, wait a second, it will be C6H12O6, concentration of glucose to the power 1 because we have stoichiometric coefficient of glucose as 1. So Kc expression will be like this. Okay, so it will be 6x to the power 6 because we have concentration of formaldehyde at equilibrium as 6x. We have concentration of formaldehyde at equilibrium as 6x. So it will be 6x to the power 6 divided by 1 minus x because we have concentration of formaldehyde at equilibrium, we have concentration of glucose, not formaldehyde. It will be glucose. Okay, so we have concentration of glucose, that is C6H12O6 at equilibrium as 1 minus x. So it will be like this. This is the expression for equilibrium constant, and we have to find the value of 6x, that is concentration of formaldehyde at equilibrium. Okay, so I'm solving it here, guys. So this Kc will be equals to 1 by 6 into 10 to the power 22, because equilibrium constant for this reaction will be 1 by 6 into 10 to the power 22. Okay, guys, like this. Now we need to just find the value of 6x. Okay, guys, so it will be 6x to the power 6. It will be equals to 1 minus x upon 6 into 10 to the power 22. Okay, so this is the value of 6x to the power 6. Okay, as you can see here, Kc, that is equilibrium constant for this reaction, for the second reaction, is 1 by 6 into 10 to the 1 by 6 into 10 to the power 22. Okay, like this. So as you can see, this Kc can be written as like this. This can be written as 1 by 6 into 10 to the power minus 22, like this. Okay, I hope you guys are understanding it. So as you can see, this Kc value is very small. Okay, this equilibrium constant for this second equation value is very small, in the order of 10 to the power minus 22. Okay, so there will be very less dissociation happens. Okay, so there will be very less dissociation happens. So we can write 1 minus x as approximately as 1. Okay, 1 minus x as approximately as 1, because we have equilibrium constant value for the second reaction is very less, in the order of 10 to the power minus 22. So we can write 1 minus x as approximately 1, because there is very less dissociation happens for glucose. Okay, so 6x to the power 6 will be, wait a second, so it will be 6x to the power 6, it will be equals to 1 divided by 6 into 10 to the power 22, like this. So value of 6x will be 1 divided by 6 into 10 to the power 22 to the power 1 by 6. Okay, the value of 6x will be like this. This 6 will be go in the right side, and with the power will be 1 by 6. Okay, so after solving this, we will get, after solving this expression, we will get 1.6 into 10 to the power minus 4 molar. So value of 6x, that is concentration of formaldehyde, concentration of formaldehyde in the solution at equilibrium will be 1.6 into 10 to the power minus 4 molar. So option second will be the correct option for this question. Thank you, guys.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.